Siberian Heatwave and why the Arctic is warming up so much faster than the rest of the world. This is on The Conversation by Jonathan Bamber, Professor of Physical Geography, University of Bristol in the UK. On the eve of the summer solstice, something very worrying happened in the Arctic Circle. For the first time in recorded history, temperatures reached 101 degrees Fahrenheit in the Arctic Circle, 38 degrees Celsius. In a remote Siberian town, 18 degrees Celsius warmer than the maximum daily average for June in this part of the world, and the all-time temperature record for the region. New records are being set every year, and not just for maximum temperatures, but for the melting ice and wildfires as well. That's because air temperatures across the Arctic have been increasing at a rate that is about twice the global average. All that heat has consequences. Siberia's recent heat wave and high summer temperatures in previous years have been accelerating the melting of Arctic permafrost. This is a permanently frozen ground which has a thin surface layer that melts and refreezes each year. As temperatures rise, the surface layer gets deeper and structures embedded in that start to fail as the ground beneath them expands and contracts. This is what is partly to blame for the catastrophic oil spill that occurred in Siberia in June 2020, when a fuel reservoir collapsed and released more than 21,000 tons of fuel, the largest ever spill in the Arctic. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. So what is wrong with the Arctic, and why does climate change here seem so much more severe compared to the rest of the world? The warning models predicted. The scientists have developed models of the global climate system called General Circulation Models, or GCMs for short, that reproduce the major patterns seen in weather observations. This helps us track and predict where the behavior of climate phenomena such as the Indian monsoon, El Nino, southern oscillations, and ocean circulations such as the Gulf Stream. And this is a simplified version of the Gulf Stream that we see here. Now, GCMs have been used to project changes to the climate in a world with more atmospheric CO2 since the 1990s. A common feature of these models is an effect called polar amplification. This is where warming is intensified in the polar regions, and especially in the Arctic. The amplification can be between 2 and 2.5, meaning that for every degree of global warming, the Arctic will see double or more of global warming. This is a robust feature of our climate models, but why does that happen? Fresh snow is the brightest natural surface on the planet. It has an albedo of about 0.85, which means that 85% of solar radiation falling on it is reflected back out in space. The ocean is the opposite. It's the darkest natural surface on the planet and reflects only 10% of radiation. It has an albedo of 0.1. In winter, the Arctic Ocean, which covers the North Pole, is covered in sea ice, and that sea ice has an insulating layer of snow on it. It's like a huge, bright thermal blanket protecting the dark ocean underneath. As temperatures rise in spring, sea ice melts, exposing the dark ocean underneath, which absorbs even more solar radiation, increasing warming of the region, which melts even more ice. This is a positive feedback loop, which is often referred to as the ice albedo feedback mechanism. This ice albedo, really snow albedo feedback, is particularly potent in the Arctic because the Arctic Ocean is almost landlocked by Eurasia and North America, and it's less easy compared to the Antarctic for ocean currents to move the sea ice around and out of the region. As a result, sea ice that stays in the Arctic for longer than a year has been declining at a rate of about 13% per decade since satellite records began in the late 1970s. In fact, there is evidence to indicate that sea ice extent has not been this low for the last at least 1,500 years. Extreme melt events over the Greenland ice sheet that used to occur once in every 150 years have been seen since 2012 and now in 2019. Ice core data show that the enhanced surface melting on the ice sheet over the past decade is unprecedented over the past 3.5 centuries and potentially over the past 7,000 years. In other words, the record-breaking temperatures seen this summer in the Arctic are not a one-off. They are part of a long-term trend that was predicted by climate models decades ago. Today we're seeing the results with permafrost thaw and sea ice melting. The Arctic has sometimes been described as a canary in the coal mine for climate breakdown. Well, it's singing pretty loudly right now, and it will get louder and louder in years to come. Please leave your comments about this. It's on conversation. Thank you for your support.